Hi friends, welcome to the interview preparation 360 digit MG. Well, today let's discuss some more questions on the topic on data science, how we are going to handle the interview questions based on that. And yeah, let me walk you through some of the important questions today. Let me open the document, Word document. All right, friends. So let's start with the first question. Let's understand what are sampling techniques. This is the most commonly asked question that we will first, whenever we are talking about the statistics and the role of statistics in our data science or building a machine model, we will first try to understand how the statistics help us in sampling the data. So this will be a very common question. What are sampling techniques? Let me write it down. Techniques. All right. So anyone want to answer? Any answers on this? What are sampling techniques? Broadly classified, there are two types in this, that is probability sampling and non-probability sampling, which is broadly classified as probability sampling, and the second one is non-probability sampling technique. All right. In probability, we can also call it as unbiased, because I'll explain what we mean by unbiased sampling. This is biased sampling. All right. So coming to probability sampling or unbiased sampling, further we have simple random sampling in this. We have stratified sampling. We have systematic sampling. We have cluster sampling, that is cluster-based sampling. And also we have multi-stage sampling. Okay, let me write it down for your reference. Further, we will classify it into simple random sampling, then we have stratified sampling, we have systematic sampling, we have cluster sampling, cluster-based sampling, then we have multi-stage sampling. Okay. However, in non-probabilistic sampling, we will have convenience sampling, sampling. Then we have purposive sampling, purposive sampling. We have quota sampling. We have referral or snowball sampling. Sampling. All right. So let's come to individual ones. What is simple random sampling? Okay. Any guesses? Anyone wants to answer this? Yes. Anyone familiar with these terminologies? Yes. Any answers? So in simple random sampling, in this case, each individual is chosen entirely by chance, right? Yes, just shuffling the data, you're right. So here each member of the population has an equal chance or probability of being selected. Okay. So this is something like how we, um, how we use the dice to roll a dice or flip a coin. These are quite simple examples that we come across every day. That is sort of a simple random sampling. In our next, this one, we have stratified sampling. What is stratified sampling? So in this, the population is first divided into subgroups or strata, who all share a similar characteristics. It is used when we might reasonably expect the measurement of interest to vary between the subgroups. And in this, we want to ensure representation from all the subgroups. Okay. So, for example, in a study of stroke outcomes, right, we may want to stratify the population by sex to ensure equal representation of men and women. And all those we try to stratify them or subgroup, make it into subgroup and divide the classes based on that. That is one way of doing it. And each make sure that each of the subgroups are of same size, right? That is the one. And coming to systematic sampling, what is systematic sampling? What is systematic sampling? So in systematic sampling, individuals are selected at regular intervals. Okay. Okay, let me write it down for your understanding. Maybe you can refer it later on. Here, each sample is chosen randomly, giving a fair chance then in stratified, we are creating subgroups or strata and classifying it based on the equal uh, number of sizes. Okay, we will try to subgroup the population, and we will make sure that all of the characteristics are shared by each one of the groups. Like we will not try to separate out. For example, if we have a classification problem and you have majority and minority class, we have to make sure that the minority class of one group, the ratio of minority class in one group is similar to the ratio of minority class in the second group as well. So as many as number of subgroups we create, we make sure that the classification or the majority and minority ratios are maintained uniformly. Okay, and then coming to the systematic. We sticks. Okay, and coming to systematic, here we are picking we are going to collect or select at a regular intervals from the sampling frame. So individuals are selected at regular intervals from the sampling frame. The intervals are chosen to ensure an adequate sample size, and thus it is more convenient. So systematic sampling is often more convenient than simple random, and it is easy to administer. However, it may also lead to bias. For example, if your underlying patterns in an order of individuals in the sample frame such that the sampling technique coincides with the periodicity of the underlying pattern, then we may get the biased sample. We have to check that. Okay. So another example I can give you is in systematic sampling, if you need a sample size n from a population size x, you need to select every x by nth individual of the sample. Okay. Here. Frame. What is cluster-based sampling? Anyone? What is cluster-based sampling? Any idea what is cluster-based sampling? So as the term cluster, you may have already understood, in a cluster sample, the subgroups of population are used as a sampling unit rather than individuals. The population is divided into subgroups known as clusters, which are randomly selected to be included in the study. Okay, the cluster sampling can be more efficient than simple random sampling, especially where the study takes place over a wide geographical region, or it involves any region or a specific area. And uh, and also the clusters should be taken into account in an analysis first. So whether how many clusters we want to make, we want out of, if we assume that the population is close to 1,000, 10,000 or 1 lakh, how many clusters can we make for this sampling? That we have to have an idea prior to it. So in clusters, subgroups of population are used as sampling unit. Okay. In multi-stage, what do we understand in multi-stage? What is multi-stage sampling? So it is very similar to our random sampling. However, in the sampling keeps changing over a period of time. Like at every stage, we try to subgroup them. The subgroup the selected individuals or the groups over a period of time. So So in multi-stage sampling, the sampling method that divides the population into groups for conducting the research. During the sampling method, significant clusters of the selected people are split into subgroups at various stages. Okay. Yeah, correct. Sampling is done at different stages. That is correct. And the size of the sample or the subgroup changes with time. So that is the one. That's the difference. And then what is non-probability sampling? Here in this we have convenience sampling, purposing sampling, quota sampling, referral or snowball sampling. So convenience sampling, as we know by the the term convenience, we try and give bias to certain classes and try to gather information or gather samples for those that category of interested samples. Okay, for example, I'll explain with an example. In convenience sampling is the easiest method of sampling because participants are selected based on availability and willingness to take part. Okay, this is a significant bias condition because we were not depending on any kind of probability here. We are totally picking what is available and what is convenient for us to pick and begin the research. So the estimation, the accuracies or the performance of the model may not be up to the expectation in this case, because the model will always seem to be biased. All right. So for some of the examples in this is so useful you can uh, because those volunteer to take part may be different from those who choose not to, and the sample may not represent of the characteristics such as age or sex, or gender. And so this is going by the definition. This is the most easiest method of sampling where the participants are selected based on their availability and willingness. Okay. Samples is purposive sampling. What is purposive sampling? This is again a very biased technique because we are not trying to get the sample from the in any specific manner, but we are reaching out to people, or we are reaching out to the interested group of people who are willing to participate in this technique. I mean, who are ready to give their samples. It could be of any type, or for example, if you're doing a medical research and you want to pick data for a set of people who have undergone some cancer or some kind of operation, and you're doing a research on the on that specific disease, right? In that case, you will reach out to those people who have already taken up. So the kind of result we get will be mostly biased, right? So that is the, so in this going by the definition, it is also as called as selective or subjective sampling technique. This relies on judgment of the researcher when choosing who to ask to participate. Okay. Purposive. And here quota sampling. What is quota sampling? Anyone? What is quota sampling? So quota sampling is a method is often used by market researchers. Okay, for example, Yeah, quota sampling is often used by market researchers. Interviewers are given a quota of subjects, okay, of specified type of attempt to recruit. For example, an interviewer might be told to go out and select 20 adult men and 20 adult women, 10 teenage girls and 10 teenage boys, so that they could interview them about their television viewing. Ideally, the quotas chosen would proportionally represent the characteristic of the underlying population. So in this, the risk involved in this is an advantage of the one thing with this is advantage of being relatively straightforward and potentially representative. Otherwise it is called quota because we are picking the samples from a fixed number of fixed characteristics of the population, right? Anyone has idea about referral or snowball sampling? Referral or snowball sampling? So this is commonly used in social sciences when investigating hard to reach groups, right? This is typically used in social sciences and investigation where the groups are not easily accessible. One of the examples could be, HIV. The people who are suffering from HIV may not be open to disclosing their details. So, if you could reach one HIV patient and then you want to do research and you want to gather more samples from them, you may get contacts from that person to many others whom he or she knows already. So that is the way why it is the name of the technique is called snowball technique because uh, existing subjects are asked to nominate further subjects known to them. So the sample increases in size like a rolling snowball. It can be also HIV patient or it could be any kind of drug users, right? Like when carrying out a survey of risk behaviors amongst drug users, they'll be able to nominate others who are involved with them. So these kind of social sciences are done using snowball sampling. Okay. Well, this is all about the sampling techniques. Let's move from this to the next question. What do you understand by standard error? Again, this is part of the basic question in statistics, which we will definitely face when we are going to attend an interview related to data science. Yeah, what is standard error? What is standard error? Anybody? So the standard error of the mean, or simply standard error, indicates how different the population mean is likely to be from the sample mean. The standard error is common measure of sampling error. Okay, basically it's the difference between the population parameter and the sample statistic. So another word we can say in statistics, a sample mean deviates from the actual mean of the population. This deviation is also called a standard error or standard deviation of the mean of population. Sample mean deviates from the actual mean of the population. This deviation is a standard error of the mean. Okay. So it is also denoted by sigma by square root of n, where sigma is population standard deviation and n is the number of samples. Okay. Next. What is margin of errors? Right? What is margin of errors? What is margin of errors? It's a very common question again. The margin of error tells you how many percentage points your results will differ from the real population value. Okay. In other words, a margin of errors is a degree of errors in results received from random sampling surveys. A higher margin of error in statistic indicates less likelihood of relying on the results of the survey or the poll. That means the confidence on the result will be reduced with higher margin of errors. Okay, is the degree of errors result results received random sampling service. So it is called as the percentage points your results will differ from the real population value. We can also say percentage points results will differ from the real population value. All right. So next question, what do you understand by type 1 and type 2 error? What do you understand by type 1 and type 2 error? Anyone? Yes. What are type 1 and type 2 errors? What are type 1 and type 2 errors? So a type 1 error occurs when the null hypothesis is true, but it is rejected. Okay. In other way, a type 1 error occurs when the null hypothesis is actually true, but was rejected as false by the testing. Okay. Here, in type 1, the null hypothesis, I would call it as HO, is true but is rejected after testing it as false. Okay. In type 2 error, here, what is type 2 error? When the null hypothesis is false, but it is not rejected. So that means null hypothesis, although it is false, it is detected as true and it is accepted. So slightly conflicting. I will first write it here and I will explain it. Fail to reject it. Hence, accepted. Is it clear? So whenever there's a null hypothesis which is false, but our detection or a test performs it as it's a true, and hence we will not be able to reject. If you find a null hypothesis which is false, we should be able to reject that, right? But here we are not rejecting it. That's when we will arrive at type 2 error. Okay. So in other words, false positive is type 1 and false negative is type 2 error. Okay. This is it. Yes, your answers are correct. False negative, true positive, false 1 minus specificity, false positive, yes. Okay. Next. What is central limit theorem? Why is it important? What is central limit theorem and why is it important? What is central limit theorem and why is it important? Right. What is central limit theorem and why is it important? Okay. To define it, the central limit theorem states that if you have a population with mean mu and standard deviation with sigma and take sufficiently large random samples from the population with the replacement, then the distribution of the sample means will be approximately normally distributed. How do we break it down into understandable way? Okay. Assume that population is mu. Okay. Mu and standard deviation is sigma. Okay. For this, we from the population mean we are going to collect the number of samples, right? Collect number of samples from this population and each sample size is large enough. Okay, we need to make sure and with replacement. Okay, what do we mean by with replacement? Why we have to mention with replacement? Any idea? With replacement. So I'll give an example. What do we mean by with replacement? So every time, assume that we have a hat and we have put about 4 to 5 different colored balls in the hat. And randomly we want to pick one ball each time. When we pick a ball, we make out of 5 balls of each of them different color, red, blue, green, yellow. white. So if I pick a ball which turned out to be blue, and then in my second attempt or a trial, I will try to pick one more ball in the second trial. Before doing that, I will make sure the first ball which I picked up, the blue color ball, is back into the hat. So every time I pick a ball, I make sure that I put it back before making the next trial. So that is called the replacement. So usually in simple random sampling, we follow the technique with replacement. So this is the central limit theorem explains us that with considering the sample size large enough, the distribution of the sample means is normally distributed, is not generally not close to normally distributed. So make sure that we are talking about means, right? We are putting all of the samples put together and we are taking the average of averages. All right. Sample means, the distribution sample means will be close to normal distribution. That means it follows Gaussian distribution. Close to normal regardless of actual population being normally distributed or not. Okay, that is the point here. Central limit theorem states that with the large number of sample sizes, when we collect it from a population with replacement, right, we are going to arrive at the sample means. That means average of averages will be close to normal distribution, regardless of the actual population being normal distributed or not. Right? This is all about the central limit theorem. So why do we consider this central limit theorem? Most of our statistical analysis follow this. For our understanding, data should be normally distributed so that many of our statistical techniques can be applied on it, especially in a continuous data. We make sure that it follows the normal distribution. Whether if it is skewed data, then we will try to normalize it. Whenever we try to build a model, we make sure that we conduct certain checks that there are no abnormalities, there are no anomalies in the data. If there's any, we will try to perform normalization and check the normality test using there's a technique called as Shapiro-Wilk test. We have to conduct that to see if the data is normally distributed or not. So having a normally distributed data gives us the best accuracy in our model. So that is why we have to consider central limit theorem. Okay. I think we have come to closing the session because we started off late today due to some technical issues. I hope to continue this in the next sessions whenever it's possible. So I hope you guys enjoyed the session. I hope it was informative. All right. Sure. Thank you so much for your time.